Step 3, props in memory. Inside the function greeting, parameter props. Prop is just a normal JS object. Like props equal this greeting member with the value hello stored in heap. So a heap, it is a linked list data structure, but again in JavaScript by default it's contiguous. But for OS, it actually uses a node data structure. So the node data structure is the one scattered in memory rather than it being contiguous. So it's lower, but it's more adaptable. Like you can delete this in the middle of the memory, or unlike an array, you cannot delete at the middle because you need to traverse all the index to get into the middle. Step 4, JSX inside returns element. Return h1 with string interpolation props dot greeting closing h1 becomes react.create element parameter string h1 comma null comma props dot greeting. So this is converted React under the hood. So this is actually its imperative programming, which becomes this object. So when you call this, it will create. So from the word create element, so as you can see, this is how the component became an element. So you create a function up and then you return an element here. So that return, you return a JSX, and that return JSX declarative become an imperative programming, and that imperative programming create an element under hood which becomes an object like this. So we have a key type with the value h1, we have a key props with the value object, and that object has a member children with the value hello. Step 5, React DOM takes over. Then React element to DOM node. So after we create this object in memory, that's the only time the React DOM client library that talks to the DOM API actually change the DOM. The reason why React DOM needs to take over because it also uses again the diffing algorithm before it pass the changes to the browser. So the React DOM change has a cache of, or has a cache or a copy of the node tree structure, and if that object really changed some node, then that's the time the React will actually call the browser API. X-ray summary of props. Here's the full cycle of props JSX usage. So we have greeting with an attribute greeting and a value hello string. When it's compiled, it will become an imperative programming which will create an object type greeting. So this greeting becomes a type. So this greeting function becomes a type in an object, and then the attribute and value of the HTML, such as props that greeting, which has hello, becomes a props key or member inside that React element object, and then it execute. Then greeting parameter props is called, then runtime, then props equal greeting hello, it becomes a heap object, then return, then it returns React element type h1 comma props with the, so props is the key with the value children hello, then it contact React DOM. It creates DOM node. Like here, h1 hello slash h1 in the actual browser. Fourth, where prop lives, stock versus heap. You asked this precisely, good. So the stock is the function calls. So any function like we discussed in the previous video, the function parameters, the function name, and then the return address or the return statement is in the stock. So here the function calls greeting is in the stock, and then the temporary execution. The heap is in the objects. So the actual value, greeting hello, and then type h1, React elements. Now, so as you can see, the h1 that we have in JSX becomes a type. So those lives in an object. So now, where does CSS live? You said since CSS is not compiled to JS, is it in heap or stock? Correct intuition. Answer: CSS is not in JS or heap. It lives in a different system inside the browser. Browser has separate engines. JavaScript engine V8, we have stock and heap. Rendering engine Blink, WebKit, or etc. We have DOM3 and CSSOM, CSS object model. So the stock and the heap model do not work with CSS because those are part of the rendering engine. So think about this like a DOM3 or the CS object that more or less already there. Like you need to work your code around there rather than them changing for your code. So you need to work their rules because the browser ultimately like providing the color, etc. The color, the structure, which is the HTML. So your CSS goes here, CSS file parsed to CSSOM3. Example, like h1, kind of like an object h1 with the member color with the value red, semicolon, becomes something like CSSOM. So it becomes selector, which is h1, and then the rule color equals to red. So it will make the h1 red. Then browser combines DOM3 plus CSSOM is the render tree. So what we're seeing in the browser is really just a tree, a render tree, a combination of DOM3 node, the CSSOM, the JavaScript stock and heap that forms the render tree. And again, JavaScript are the only language that can run into the browser, and if other language wants to run in the browser, they need to be converted in JavaScript. Then layout to paint to pixels. It will start with the layout, like a template first, like a skeleton, and then it will paint that, and then last is the pixel. So CSS is not part of React pipeline. Important correction. JSX React elements to DOM nodes. CSS separate, applied afterward. They only meet at actual DOM nodes. So the JSX is just a React elements, or think about that as a node, the HTML or the node tree. We're changing the node tree in the browser using React elements. So we're using this rule or React elements to actually change the DOM node in the browser. Now CSS is a separate and then applied only after the layout. So they only meet at actual DOM nodes. Where index is CSS is executed, when you write import ./index.css semicolon, your bundler turns it into something like const style equal document that create element parameter style semicolon next line style that text content equal your CSS, then next line document that head that append child parameter style. So the bundler along with the JavaScript and HTML bundler, or sorry, along with the React bundler, gets bundled with CSS. As you can see, it's just a code as well. It used const style and then document that head append child, which is the enter style. So CSS is injected into DOM, parsed into CSSOM, not stored in JS heap.